Welcome to my first video. If you ever used a computer, played a video game, or even used a calculator, you've interacted with one of the most important concepts in all of technology, variables. Think about your favorite video game for a second. How does the game know how many lives you have left? How does it remember your character's name or the high score? It doesn't just know. It uses variables to keep track of that information while the program is running. In this video, we're going to dive deep into what variables actually are, how your computer stores them in its brain or memory, and the rules you need to follow to talk to your computer effectively. By the end of this, you'll understand the grammar of variables and how they form the backbone of every program you'll ever write. So, what is a variable? Simply put, a variable is a name that refers to a value. A common way to think about this is a box, but let's make it even simpler. Imagine a name tag. In programming, you have a piece of data, like the number 10. To make it useful, you slap a name tag on it called score. Now, whenever you tell the computer to look at score, it knows exactly which piece of data you're talking about. Variables allow us to use names that make sense to humans, like user email or total price, instead of forcing us to remember exactly where the computer put that data. It's the difference between saying go to the third house on the left and saying go to Sarah's house. But where do these values actually go? They live in your computer's RAM or memory. Think of your computer's memory like a massive hotel with millions of tiny rooms. Each room has a unique room number, which programmers call a memory address. When you create a variable, two things happen. 1. Python finds an empty room in the hotel and puts your data inside it. 2. It writes your variable name on the door of that room. So, when you type age equals 25, Python isn't just making a note. It's physically reserving space in the hardware of your computer to hold that number 25. If you ever want to see the specific room number or address Python assigned, you can use a special tool called the ID function. It's like asking the hotel clerk for the key card to that specific piece of data. In math, the equal sign means this side is the same as that side, but in programming, it's called the assignment operator. It's better to think of it as an arrow pointing to the left. Python follows a very specific evaluation order. It always looks at the right side first. Take the line result equals 10 plus 20. Python doesn't look at the word result yet. First, it does the math on the right. 10 plus 20 becomes 30. Only after it has that final result does it assign it to the name on the left. This is why you can do something that looks impossible in math, like x equals x plus 1. In a math class, that's nonsense. In programming, it just means take the current value of x, add 1 to it, and then put that new result back into the name x. Just like a language has grammar rules, Python has rules for how you can name your variables. If you break these, your program won't run. The first rule is no numbers at the start. You can use numbers, but not as the first character. Player 1 is fine, one player is a mistake. Second rule, no spaces. Use underscores instead. Third rule, letters and underscores only. Aside from numbers, not as the start. Don't use symbols. Number 4. Reserved words. Python has secret words it uses for its own logic, like if, else, while, or true. You can't name your variable if because Python will get confused about whether you're starting a logic gate or naming a piece of data. Fifth rule, case sensitivity. Capital and lowercase letters are treated as different. Variables are variable because they can change. This is called reassignment. Imagine you're tracking a player's health in a game. At the start, health is equals to 100. When the player takes damage, we reassigned it. Health equals to 80. The old value 100 is thrown away and the name tag now points to 80. This leads us to a concept called program state. The state of your program is simply the collection of all your variables and their current values at any given moment. By tracking how variables change over time, like a clock ticking up or a bank balance going down, you are tracking the life of your program. Understanding how to manage this state is what makes you a true programmer. Variables are the building blocks. They allow your program to remember things, change things, and stay organized. Now that you know how to store data and name it, you're ready for the next step. In our next video, we're going to learn how to actually get information from the user, the input, and how to show our results back to the world, the output. Thanks for watching and keep practicing your variable naming.